Hello friends, welcome to Math Solution Academy. Now we talk about real analysis. Now my topic is series of functions, and the problem is whether the series is uniform continuous or not, and this is equivalent to the sum of this series of function is continuous or not. The problem is defined f1 f2 being functions from closed interval 0 and 2 are defined by f1 x equal to summation n1 to infinity x sine n square x by n square, and f2x equal to summation n1 to infinity x square 1 minus x square whole to the power n minus 1. Then the fourth options are f1 is continuous but f2 is not continuous, f2 is continuous but f1 is not continuous, and third options are uh, both f1 and f2 are continuous, and the last option is neither f1 nor f2 are continuous. Now we read the first equation. F1 x equal to x sine n square x by n square, and this is a series of function. This function can be written as n1 to infinity fn x, where fn x is a sequence of functions. Now mod of fn x, this is equal to mod of x sine n square x by n square, and this is less than equal to n square mod x, and you know that mod of sine n square x, and this is strictly less than 1 by n square, since x belongs to closed interval 0 1, and you know that the greatest value of sine n square x is equal to 1. So from this we say that fn x is uniformly and absolutely convergent to the sum function, uniformly and absolutely convergent on 0 1 by 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 m test. And since this is, first of all, since 1 by n square is convergent, so summation fn x is uniformly and absolutely convergent on closed interval 0 1 by mu test. So so the first so the sum functions n1 to infinity x sine n square x by n square is continuous since each fn x is continuous on first interval 0 1. So that's why f1 x is also continuous. Now we check the second case. Second case tells f2x equal to summation n1 to infinity x square 1 minus x square whole to the power n minus 1, and this can be written as, and say it fn, and denote it another case fn2 x n1 to infinity. And now we take the sum functions sn2x, and this is f, and take it fn dash not 2, so n dash, and this is f1 dash plus f2 dash dot 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 fn dash, and this is equal to x square 1 minus fn, so this is x square plus x square 1 minus x square plus dot 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 x square 1 minus x square whole to the power n minus 1, and this can be written as x square 1 plus 1 minus x square dot dot 1 minus x square whole to the power n minus 1, and so this can be written as 1 minus x square whole to the power n by 1 minus x square. So this is generally 1 minus x square whole to the power n, where x greater than equal to 1 less than equal to 0. Now friends, you see that at so Sn dash x is equal to 0 if x equal to 0, and this is 1 if call it Sx, and Sx less than equal to 1 greater than 0, and just tell it Sn dash and limit n dash tends to infinity, and this is equal to Sx. So this is limit n tends to infinity Sn dash x, and this is 0 if x equal to 0, and this is so. From here we say that s of x is discontinuous at 0, and since the functions Sx is here discontinuous, and actually f for f2x is equal to s of x, that means limit n tends to infinity, this is Sn dash x. Since Sn x is the summation of nth term of this degree of this nth term of this function, so f2x equal to sx equal to limit n tends to infinity Sn x. So that's why f2x is not continuous, since this is hold. So we say that the options f1 is continuous but f2 is not continuous is right options, and the remaining three are false. Thank you.